These notes are exciting because we get to discuss forces that you've probably actually run into in your everyday lives. Because today we're talking about everyday forces. Your goals for the end of this lesson of notes is to be able to describe the following everyday forces. Weight, something that we call the normal force, which you'll learn what it is. Friction, and air resistance. You should also be able to calculate the force of friction if you are given the coefficient of friction, which you'll learn what that is. And you should be able to list the 4 fundamental forces that run everything in the world.
So the weight and natural force of friction,
They're actually different.
Oh.
Okay. All right. Beginning with weight. You're familiar with the concept of weight in terms of how you have experienced it your whole life. Okay? Weight, as science defines it, is a measure of the pull of gravity on an object. So when you step on a scale and it tells you your weight, it's actually telling you how hard gravity is pulling on your mass. On Earth, we can calculate the force of friction using the equation, the force of gravity, or your weight, by using the equation force of gravity is equal to your mass times the acceleration due to gravity, which we know is 9.8 meters per second squared. 9.81 meters per second squared. Okay? Weight is not an inherent property of an object like mass is. So an object's mass is set. It doesn't change. It's inherent to that object. Unless you remove a portion of that object, its mass isn't going to change. However, weight is not like that because weight is due to gravity. So if you are able to change the force of gravity, then your weight will change even if nothing else about the object changes. Gravity can change when objects move to another planet. Okay, so if an object moves to a planet that has less gravity, then that object's weight would change. Gravity is also affected by altitude and latitude. So if you change your latitude on the globe, gravity changes a little bit, but where you're going to experience more changes is in altitude. So if you go up really high, gravity is slightly weaker because the further you get from the surface of the Earth, the less strong gravity becomes, okay, which is why astronauts that are on the space station experience semi-weightlessness, but not total weightlessness, because they still do experience some pull from gravity, but they're so far away from Earth that they don't experience the full force of gravity. So their weight changes. Gravity on the moon is about 1/6 of what it is here on Earth. So if you went to the moon, your mass would stay the same, but your weight would drop by about 1/6. It would become about 1/6 of what it is here, because of the significantly less strong force of gravity. All right, normal force. This is a force that acts on every object that is sitting on a surface. So all objects sitting on a surface, from you sitting on your desk chair to your iPad sitting on the top of your desk, those are all experiencing a normal force. Okay? This normal force is perpendicular to the surface and in the opposite direction. Well, sometimes in the opposite direction, but always with an opposite magnitude. So the normal force is responsible for the fact that you sit down on that chair and you do not continue to move downward. It balances the force of gravity. And if the surface is parallel to the surface of the Earth, then that force, the normal force, will be in the opposite direction to gravity. However, surfaces aren't always exactly parallel, so it's not always directly opposite. Okay? Think of a box sitting on a slope. The force of gravity is pulling downward, but the normal force will be perpendicular to the slope. So think you have your slope like this, you have your box sitting on the slope. The force of gravity pulls down on the box like this, but the normal force would be in this direction. So in this case, only the y component of the normal force would be in the opposite direction to the force of gravity. If the surface that the box was sitting on was parallel to Earth, then the force will be directly opposite. But if the surface is not parallel to Earth, then it won't be directly opposite, because the normal force is always going to be at 90 degrees to the surface.
Gotcha.
So,
Not to where the Earth is, but
right, to the surface the object is sitting on.
Gotcha.
So if you tilt that surface, then the normal force also tilts.
Gotcha.
Okay. Now let's talk about friction. The first two were short. Friction is a little more complicated. Okay. You have experienced friction in your everyday life. You know that friction is constantly working against applied forces. When you try to drag your dog who has stopped walking on their leash, you experience friction between your dog and the ground. When you try to push your bed while you're rearranging your room and it gets stuck in your carpet, you're working against friction there. So it's always working against you. It's even working against you when you are pushing on an object and that object is not moving. Okay, so this nice fancy cup that's sitting right here, we all know that while it's sitting here, forces are balanced on it, because we've discussed that. But it is possible for me to apply a level of force with my finger and have the cup not move, right? Which would seem to imply that there must be a force that is opposing the weak force that I'm applying with my finger, and that force is friction. Okay? So even when objects are not moving, they are experiencing friction. Static friction is the name of friction between a surface and a stationary object.
So that would be your cup.
Right, that would be the cup in the example. Okay? It's opposite in direction to the force being applied. So when I was pushing the cup forward, friction was pushing back against me, so in the opposite direction on the cup. And because those forces were balanced, the cup didn't move. What's interesting about static friction is that it will increase as your applied force increases. And it will increase proportionally, so it will match your force up until the point that you reach the maximum of static friction for that surface, and then the object moves. So when let's say you have a really heavy object, like a refrigerator, that you're trying to move, right? As you're pushing on it, you're going to increase and increase and increase the force with which you're pushing, and static friction is going to increase and increase and increase and increase the force with which it's pushing back, until you generate enough force to overcome the force of static friction, and at that point the object will begin to move. So the instant right before the object moves, that's what we would call the static friction being at its max. And what the max of static friction is different depending on which two surfaces are in contact with each other. It would obviously be different if you had a more massive object, and it would be different if you had a rougher surface. So,
Like carpet versus tile.
right, carpet versus tile, sand versus grass, it's going to be different. Kinetic friction is what takes over when you overcome static friction. Kinetic friction is the friction between two surfaces where one of those surfaces is moving past the other.
Gotcha. So like a ball rolling on a flat.
Yes. Or me finally being able to push this cup across the desk. As it's moving, there's still friction there. But it's still opposite in direction to the force, but it's always less than the maximum of static friction, so it's weaker, which is why I'm then able to move the object. And if you subtract the force of kinetic friction from your applied force, you will then find the net force acting on that moving object. The force of friction is proportional to the normal force. And if you remember, the normal force is the same in magnitude to the force of gravity, just in a different direction. So what that means that is as an object's mass increases, and the normal force increases because its mass is increasing, then the force of friction between that object and the surface also increases, which I am certain you have experienced when trying to push a heavy box full of things across the surface. It's much more difficult to do than an empty cardboard box. You have more friction there.
Okay, so you just stop and
The coefficient of friction is something that it's a number that you will be given that expresses the types of surfaces in contact with each other and how they affect friction. So remember how I said that depending on if you have a rough or a smooth surface, that you're going to have different forces of friction? Well, the coefficient of friction is a way to express that. It is because not only the increase in normal force from more massive objects, but also the quality of the surface and the composition of the surface that are sliding past each other are going to affect the forces of friction.
So like we said, the carpet and tiles.
Right. Like our example of carpet versus tile. Those surfaces, there's so many different surfaces with so many different textures and levels of roughness and smoothness that it's going to be different every time you put two surfaces together.
Would glass be the smoothest surface?
Glass is pretty smooth. The thing is, all surfaces at a microscopic level, even if they appear smooth, are still pretty rough. And as we're going to discuss later, a lot of friction at the microscopic level is caused by attraction between particles and not surfaces. So even smooth surfaces experience friction because they are still made of particles that have electric charges that are attracted to each other. So even the smoothest of surfaces would still experience some friction. The only way to avoid friction entirely would be to have no surfaces touching each other.
But then you have air resistance.
True. So you'd have to eliminate the air. So in the void of outer space is one of the few places where we would find a truly frictionless environment.
Which is why objects continue to move.
Yes. The coefficient of friction is a ratio of the force of friction compared to the normal force. So it's represented by the Greek letter mu, which is that fun little symbol there, which should be the command button, and the letter M on your computer should produce that symbol. I looked it up. You can calculate the coefficient of kinetic friction, which is mu sub k, by doing the force of kinetic friction divided by the normal force. And you can do the coefficient of static friction the same way, just using the maximum static friction force divided by the normal force. However, in a lot of problems, what you're going to see is that they actually give you the coefficient of static friction and ask you to solve for the force of friction. Given what we now know about friction, you can actually calculate the friction on an object if you have both the coefficient of friction and the normal force, or if you have the force of gravity and the mass of the object, you can calculate the normal force and then use this equation to solve for the force of friction. So in this equation, F sub F is the force of friction, and mu is the coefficient of friction, and then F sub N is the normal force on the object. So if you have, 2 out of the 3 of these things, you can calculate the other one using algebra, basically. And given that class is going to end in about 2 minutes, I think we'll stop notes here and we'll pick up with the rest of them on Monday.